If the side towards the center of curvature is the shiny side, then the type of mirror is. So what is the name of this mirror? Question says, look at this mirror and tell us the name of this mirror. What is the name of this mirror? Concave or convex? What do you think? What is the name of this mirror? Do you remember? The name of these types of mirror is concave mirror. Now, there is a term you might notice, center of curvature. What do we mean by center of curvature? Suppose this is your mirror and you want to find the center of curvature. How are you supposed to find the center of curvature? Well, let's just imagine that we extend the mirror, okay? So you can imagine the extension forms a complete sphere. Oh, nice. Now there will be some center of the sphere, right? Right. The center of this sphere will be the center of curvature of this mirror also. Okay. So this is how you can imagine the center of curvature. Now, if the side which is facing the center of curvature is the shining side, then we assign this type of mirror a special name, and the name given to this mirror is concave mirror. The name given to this mirror is concave mirror. Just don't forget this name. Now, in case you are in habit of forgetting the names, then I might give you something to remember. See, imagine a cave with the shiny side inside the cave. Okay? So, now you can relate. This is just for memory. This is not a concept. So, now you can relate. We have the inner side as the shining side, the inner side as shining side, and we have a cave. So, these types of mirrors are concave mirror. Okay? This might help you to remember. It is not a concept. So the answer for this question is option A, concave mirror. So guys, let's have a look at this amazing question. The focal length of a plane mirror is. So what is the focal length of a plane mirror? Options are 0, infinity, greater than 0, less than 0. So what is the focal length of a plane mirror? This is the question. Now, what do we really mean when we say focal length? What is the focal length? Well, in case of curved mirror, it is very easy to determine the focal length. Focal length is just the distance between the pole and the focus of the mirror. All right. How do we find where is the focus of the mirror? Well, that is very easy. Imagine some rays which are parallel to the principal axis and very close to principal axis. After reflection, they might meet or appear to meet at a single point. So that special point at which the rays after reflection meet or appear to meet is known as focus of these mirrors. Okay. So the distance between the focus and the pole of the mirror is known as focal length. Amazing. We got the concept of focal length very clear to us. Now let's imagine these parallel rays in case of plane mirror. So they were parallel before the reflection. What will happen after reflection? After reflection, we can say that they are again parallel to each other. Oh, nice. So this means they will not meet. They are parallel to each other. If you imagine the focus will be at infinity and the focal length will be infinity. Option B, infinity, is the right answer. Now, there is another way to visualize this question. What is the other way? Well, the other way is like this. I will ask you, where is the center of curvature of this plane mirror? For the curved mirror, you can just say that we can imagine they are part of a very large sphere. Okay? Yes. Now, if you increase the radius of this sphere to be infinity, then you can find that we will get a plane mirror. So, the section of a really large sphere whose radius of curvature is actually infinity, the section of that sphere is a plane mirror. Okay, now we can imagine the plane mirror. So, what is the radius of curvature of the plane mirror? Infinity. And there is a relation between the focal length and the radius of curvature. The approximate relation is like this. Focal length is equal to radius of curvature divided by 2. So if radius of curvature is infinity, focal length will also be infinity. So for this question, we can mark option B infinity as the right answer. Let's see this good question. A concave mirror has been used to focus the incident beam of paraxial light rays to a single point. Now, to achieve the highest accuracy while converging the beam to a point, the mirror used should have. So, what are we doing? We are using a concave mirror to converge the light rays at a single point, and we want the highest accuracy while converging these light rays. And our mirror used should have option A, aperture comparable to the radius of curvature. Option B, very small aperture compared to the radius of curvature. Option C, very large aperture compared to its radius of curvature. And option D, aperture of the mirror doesn't have significant role. Well, aperture of the mirror does have significant role. I will show you how. First of all, let's talk about the actual definition. What do we really mean when we say aperture? And what do we really mean when we say radius of curvature? Let's be clear with these definitions first. So, radius of curvature. You can imagine our curved mirror to be a part of really large sphere, and the radius of that really large sphere is known as radius of curvature. Okay? Okay. We understand radius of curvature. And there is a point known as center of curvature. This is the center of our imaginary sphere. Okay. Now, let's talk about aperture. So you can see we have two different types of curved mirrors, concave mirror and convex mirror. So let's talk about the aperture for a while. Aperture, what is this aperture? Aperture is the segment of the mirror available for reflecting light. Segment of the mirror available for reflecting light. This is the aperture. Did we get it? Yes? Yes. Now, we have talked about the center of curvature, the radius of curvature, and the aperture. Let me give you two more definitions at a point. So at this point, we define something known as principal axis. Principal axis is the line which is passing through pole and the center of curvature. What is this pole? Pole is the center of this aperture. So we also know what is the pole and what is the principal axis. Amazing, amazing. Now, principal axis is really crucial. We will talk about why it is crucial. So, before that, let me give you why the aperture has a significant role when we want to converge the light beams to a single point. So, let me just say we have angle of incidence as the angle between the incident light ray and the normal. And all the normals of this mirror will pass through the center of curvature. Can you imagine that? Yes, we can. So this is the angle of incidence between the light ray and the normal. Now, let's talk about different light rays. So you can imagine we have different angle of incidences, right? Right. Okay, so we know according to the law of reflection that angle of incidence is equal to angle of reflection. Do we know that? Do you know angle of incidence is equal to angle of reflection? Yes, we do know. This is a baby stuff. Okay, nice. So let's see the reflected light rays. So you can see we have these reflected light rays, and when they meet the principal axis, they meet at different points. So you can say that each line has its own focus, and these points are not coinciding with each other. Now, what if we want the light rays to meet at a single point? Then aperture plays a really crucial role. What I will do is I will reduce the aperture. See, this is how I reduce the aperture. Okay. So, in this portion only, I will just use the mirror, and rest of the mirror I will remove it. Okay. So, this portion is removed. Amazing. Now, you can just see that angle of incidences are almost the same, and these light rays are very close to our principal axis. Okay. So we can say closer the incident rays to the principal axis, the more concurrent the reflected rays are. Yes, and we can see they are meeting at a single point, and this single point is known as focus, and we have an interesting relationship. This distance is r by 2 and this distance is also almost r by 2. Okay, amazing. So we talked about what we will do to converge the light rays at a single point. We will reduce the aperture. So aperture should be really less as compared to the radius of curvature. Nice, nice. We got it. Now let's go back to our question. So we can see that option B, very small aperture. This is the right option for our question. And what did we learn from this entire story? The key takeaway is, in order to focus the incident beam concisely to a single point, the region of the incoming incident beam needs to be restricted. This is our key takeaway. So option B is the right answer for this amazing question. Let's see this interesting question. Which of the following statement is incorrect with regard to sign convention of spherical mirror? So we have to pick the incorrect option and we have to talk about the sign convention for spherical mirrors. Now before we read each of the options, let's talk about the sign convention generally. So here we have the mirrors and here are the incident light rays. Amazing, good. Now one direction along the principal axis we will take as positive and one direction will be taken as negative. Okay? Okay. Which direction should we take as positive? Well, we can see the direction of incident light rays, right? Right. So this direction will be taken as positive. So these are the directions. So we can see we have positive direction on this side and opposite to the positive direction we have negative direction. So what have we learned? We have learned that all the distances are measured from pole. The direction of the incident light ray is taken as positive. The direction opposite to incident light ray is taken as negative. So you must measure all the distances from pole. This is very crucial. You can always take the pole as our origin. You can take the pole as our origin and you can take the x-axis along the principal axis and you have to choose the x coordinate as positive or negative as per the direction of incident ray. The coordinates in the direction of incident light ray are taken as positive. Okay? Okay. Now there are two portions. One is above the principal axis, one is below the principal axis. The portion which is above the principal axis will be taken as positive direction along the y-axis. And the portion which is below the principal axis will be taken as negative direction along the y-axis. Okay? Okay, we got everything. Now, let's see the options. So we can see that option A says all the distances are measured from pole. This is actually true. So we take this as convention. And option B, the direction of incident ray is chosen to be positive. This is also true. The direction opposite to the incident ray is chosen as negative. This is also true. So option D has to be false. Option D says the direction of the incident ray is chosen to be negative. So this is false. The direction of incident ray is chosen as positive. Got it? Got it. So we had to choose the incorrect option. We pick option D as the answer for our question. What is the key takeaway for this question? The key takeaway is, as per the sign convention, the direction of incident ray is chosen to be positive and the direction opposite to it is chosen as negative. This is clear? Okay, it is clear. Now at this point, let me ask you one more question before going to the next one. So the question is like this. Suppose this is our mirror and this is the incident light ray. Okay? Okay, we can see the direction of incident light ray. Now, just tell me which of these two direction is positive or negative. This is direction A, this is direction B. Which direction is positive, A or B? Which direction is positive, A or B? Did I hear A? Are you saying A? Yes, A is the positive direction, you are right. And B will be the negative direction. A is positive, this is along the incident light direction. And B is negative, this is opposite to incident light direction. Okay, nice. So you have solved this problem. Option D is the answer for our question. Let's see this question now. It is based on sign conventions. An object AB of height 5 cm has been kept at a distance of 30 cm in front of concave mirror with the radius of curvature 50 cm. So our mirror is concave mirror. Concave mirror means the shiny side is facing the center of curvature. So you can see here we will find the center of curvature C. Now the radius of curvature is already given. It is given to be 50 centimeter. So this distance is 50 centimeter. By the radius of curvature, we mean the radius of the entire sphere from which we cut out this mirror. Okay? Yes. Now, which of the following is incorrect as per the sign convention? So we have to pick the incorrect option. Don't pick the correct option. Pick the incorrect option. These are the options. So we will find out which of these are true and which one is false, and we will pick the false one. Now, option deals with focal length, the object distance, and the radius of curvature. So we have to tell what are their values with their exact signs. Now let's see. Let's find out everything on our own. So we will find out what is the radius of curvature R, what is F, and what is the object distance U. And in addition to that, I will also tell you how to write the perfect sign for H. H is AB. Okay? Okay. Now, R. R is the radius of curvature. So, first of all, we must know which direction is positive and which direction is negative, and from which point we are measuring the distances. Now, the first thing first, we must measure all the distances from the pole. So we can assume our origin at the pole itself. So pole is at origin or origin is at pole. All the distances are measured from pole. Now let's talk about positive direction and the negative direction. Now we can see here are the incident light rays on the mirror. In which direction they are pointing? They are pointing away from the tree in this direction. So this direction will be taken as positive direction. The direction of incident light rays is positive direction. And the direction opposite to incident light rays is the negative direction. Okay? Okay. Got it. Got it. So we know the directions. Now, on which side, positive side or negative side, do we find the center of curvature? Center of curvature is on positive side or negative side. What do you think? It is on negative side. Correct. So we measure the distance from the pole and we can see the center of curvature is on negative side. So I can write radius of curvature as minus 50 with the correct sign, minus 50 centimeter. Now, we have to find the focus. So this is our focus. You know the focal length. Focal length is equal to R by 2. Right? Right. R is given to be 50. So 50 by 2 will be 25. Now, let's see on which side we have focus. On positive side or negative side? What do you think? Focus is on positive side or negative side? Focus is on negative side. Why? Because when parallel light rays strike on this mirror like this, these are the parallel light rays which are parallel to the principal axis also, and they are very close to principal axis. So they will meet at focus, and we can see the focus will be on the negative side as we have our concave mirror. Okay? Okay. So this is our focus, and we know F is equals to R by 2. So R was given to be 50. 50 by 2 is 25. But we have to take the negative sign. So I will write minus 25 centimeter. And what is U? What is U? Object is on negative side. We can see that. So U is minus 30 centimeter. Now comes h. So all the distances above the principal axis will be taken as positive. All the distances below the principal axis will be taken as negative. This is another rule. So if we want to write h height of the object, we will write it as plus 5 centimeter. Got it? We got everything. Correct, correct, correct. Now let's see the options. So here are the options. Option A, focal length of the mirror is plus 25 centimeter. Is it plus 25? No, it was minus 25. So option A is false. Option B, object distance is u equal to minus 30 centimeter. Is this the object distance? Yes, it is minus 30 centimeter. So option B is true. Option C, focal length of the mirror f is equals to minus 25 centimeter. This was true. And option D, radius of the curvature of the mirror r is equal to minus 50 centimeter. Was it minus 50? Yes, it was minus 50. So option D is also true. So we have to pick the incorrect option. So we can pick option A as the answer for our question.